Hello guys, welcome to this lesson, which is lesson 6.2. It's about centers of triangles, most of them involving circles. So to start, we're gonna talk about what is a concurrent line, okay? So we can say that three or more lines are concurrent when they intersect each other at a single point. Particularly in triangles, the name of this intersection is called the point of concurrency. So let's go ahead and fill in the blanks here, which what I just told you. So when three or more lines intersect at a single point, okay? And the name of this intersection in triangles is called the point of concurrency. So now that we know that, we can go ahead and discuss these two different theorems. The first one is called concurrency of perpendicular bisector theorem, and the second one is called concurrency of angle bisector theorem. So let's start with this one. So it says that the point of concurrency in this theorem is called the circumcenter. So let's write it here. Circumcenter. So in this case, we can say that the circle is outside of the triangle. In this case, as you can see, this is the triangle and the circle is outside the triangle. So we're going to say the circle is outside of the triangle. In math, we usually call a figure that is outside another one, we call it circumscribed. Okay, in this case we're going to say that this figure is, let me write a little bigger, is circumscribed. Okay, so as you can see here, this theorem has different things that we need to have in mind. So for example, in this case we're going to call this the circumcenter, right? So this point over here is the circumcenter. As you can tell, these two distances that have these two lines are the same. These two lengths over here that have the three lines are the same. And these two lines that have the single line here are the same. So we're gonna fill these blanks as well. So it says the circumscribed point C is equidistant from the vertices. From the vertices in the triangle. What do I mean by vertices? The vertices of a triangle are this one, and this one. Every triangle has three vertices, okay? So we can say that this point over here is equidistant from this, and from this. This distance, and this distance is exactly the same, okay? So we're gonna say if a point C is the circumcenter, if a point C is the circumcenter, then we can say in this case, this distance, which is QC, right? QC, which is this distance, is the same as the distance CS, which is this distance, and is the same as the distance CR, which is that line that I just draw. Okay, so in this case, we're gonna say, okay, the segment, sorry, the segment QC, right, is the same as the segment RC, right, and is the same as the segment SC. That's what I just said. So QC, which is this one, is the same as RC and the same as AC. These three, again, are the same. Okay? So here's an important note. The circumcenter of a right triangle is always at the midpoint of the hypotenuse. So let's write it here. It's always at the midpoint of the hypotenuse. Let me do a little drawing here so you understand what I'm talking about. So let's imagine for a moment that you have a right triangle here. Let me put it here in another color, maybe blue. Okay, it's a right triangle. Why? Because remember, in right triangles we can recognize them because they have a right angle here, right? Okay, so whenever you have a right triangle, okay, whenever you have a right triangle, the circumcenter is gonna always be in the midpoint of the hypotenuse. Which one is the hypotenuse? The longest side. So in this sketch that we're doing here, the midpoint is over here. So in this case, I'm gonna say, okay, the circumcenter in this case is gonna be this one. So in this case, we're gonna say that this is the circumcenter. Okay? So that's what is regarding this concurrency of perpendicular bisector theorem, which is this one. Now, let's discuss about the concurrency of angle bisector theorem. This one says the point of concurrency in this theorem is called the incenter. So we are not talking about circumcenter anymore. Now we're talking about incenter. Okay? So in this case, is the opposite. In the previous one, the circle was outside of the triangle. Now, in this case, the circle is inside of the triangle. So, in this case, we're going to write the circle is inside. Now, when something is outside, we call it circumscribed. But when it's inside, in math, we call it inscribed. Okay? Inscribed. So, let's talk about this theorem more in depth. It says the inscribed point I, which is this one, right, is equidistant. Equidistant. Equidistant from the sides in the triangle. So what do I mean by this? So this distance, and this distance are all of them the same, right? So what is important here? That the line that connects the incenter with the side of the triangle, which is this one, it has to form a 90 degrees angle. Let me just put this 90 degrees here. So in this case, this line with this side creates this 90 degrees, right? This line with this side creates this 90 degrees, right? And this line with this side forms a 90-degree angle. Okay? So in this case, we can say that the distance xi is the same as the distance zi, which is this one, and it's the same as the distance iy, which is this one. Got it? So we're going to put this information here. I can say, okay, the distance xi is the same as the distance zi, and it's the same as the distance yi. Okay? So, what I need you to understand here is between these two theorems, in the first one, the distance is from the point to the vertex of the triangle. This is one vertex, this is another vertex, and this is another vertex. But in this theorem, the distance is from the center, well, from the in-center to the sides of the triangles. In this case, we don't talk about the vertexes anymore, okay? So let me just put this in colors so you can understand it better. So in this case, which is called the circumcenter, these lines are the same. I'm just gonna put them in another color so you don't get confused. Okay, hold on, let me fix this a little. Okay, so what I'm saying here is these three distances are the same. So as we're using 1, 2, and 3 lines, we're gonna call this one 4 lines. So let's call it 4 lines. So this distance with 4 lines is the same as this distance with 4 lines, right? And it's the same as this distance with 4 lines, okay? And in this case, it's similar, but it's not with the vertex, it's with the sides. So we have this one, we have this one, and we have this one. So in this case, well, as we are not using lines in this triangle for the sides, so we can just say, okay, this, and this are exactly the same, okay? Sorry guys, I put this in the wrong line. So this goes here. And in this case, they were saying, sorry, my bad. In this case, they were saying, okay, this point I over here is called the in-center. My bad, I put in the wrong spot. But you get the point, right? Okay, so do you remember, guys, that in the previous theorem, which is this one, I talk about this important note that says the circumcenter of a right triangle is always at the midpoint of the hypotenuse. So the hypotenuse is this one, the midpoint is just half of the distance, right? So what is the formula of the midpoint? So guys, I'm just gonna write it here, but whatever I write here makes part of this theorem, okay? It doesn't make part of this one, okay? What I'm gonna write here is part of this one, okay? So that's why I'm gonna just do this. Let me put this arrow here, indicating that this is part of the other theorem, okay? So we're gonna write here, I'm gonna give you the formula of the midpoint. Okay, so whenever you have 2 points, let's imagine that you have 1 point here and 1 point here. Hold on, let me put it like this, better. 1 point here and 1 point here, and we're gonna connect them, right? And we're gonna say that, for example, the coordinates of this point are x1, y1, and the coordinates of this point are x2 and y2, right? How do I find the formula, or the formula, no, the coordinates of the center of that distance, okay? So let me just put a little better here. Let me draw it again. How do I find the distance, the coordinates of this point, the red point, right? So that's how we're gonna find the coordinates of that point over here. So let's say the coordinates of this point are going to be x midpoint, y midpoint. But how do I find these numbers? So to do that, we're going to use a formula. The formula says the following. The order pair xm ym, you can find it just doing the following. What you're going to do is, hold on, you're going to add the x coordinates and you're going to divide them by 2 because we're finding the midpoint. Midpoint means we're dividing by 2. Okay? And then you're going to take the y coordinates, you're going to add them, and you're going to divide them as well by 2. So if you do that, you're going to be able to find the coordinates of the midpoint, which is this one. Okay? So I'm going to put this here so you know what formula are we going to use later. Okay? So let's go ahead and solve some exercises so you can understand this topic a little better. Okay? So example number 1, find the circumcenter point P given a graph of a triangle or its vertices. So in the first one, we have this triangle over here, right? So as they're talking about circumcenter, what do you think what theorem are we going to use? The one that says circumcenter or the one that says incenter? Of course it's this one because we're talking about circumcenter. We're not talking about incenter, so we're not going to use this one. We're going to use this one. So remember that, okay, let's analyze the first triangle. The first triangle is a right triangle. Why? Because we can easily identify here that we have a right angle over here, which is how many degrees? 90. Yes or no? So, as I told you, well, let's read this note again. It says, the circumcenter of a right triangle, which is this one, right, is always at the midpoint of the hypotenuse. How do we find the midpoint? Using this formula, right? So, in this case, you can do it, of course, using the formula, right? Let's do it. Well, but what I want to say to you in this case is, okay, we can use the formula, but also sometimes when you are taking the EOC test, you don't have time to do a lot of things. I mean, your time is going to be very limited. So if there's another way to find it faster, you have to go that way. Anyway, I'm going to solve it using the formula, and I'm going to solve it using just my intuition, my eyes. Let's do the intuition first. So let me show you here. The hypotenuse, of course, is this one, which is the longest side, right? From this longest side, you can tell, using your eyes, the half of it is here, right? So technically, I found the midpoint already. And I can say, okay, the coordinates of the midpoint are, let's grab them here. So the coordinates of the midpoint are, in this case, -2 and -3, right? So the coordinates of the incenter, of the circumcenter, sorry, is -2, -3. Okay, anyway, as I told you, we can use this formula still, right? And I'm gonna show you how to do it using the formula. I'm gonna do it here, very small, but you know, whenever you can use your eyes to get the answer faster, please don't use formulas if you don't need to, because you're gonna be wasting time. But anyway, let's do it. So as I just told you, the formula of the midpoint is, okay, x midpoint y midpoint is equal to x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2, right? So Let me put this a little better here. Okay. Okay. So who is x1 and who is x2? Let me just bring this here so you can see better. I'm going to put this here. So as we are finding the distance between this point and this point, this is going to be the first coordinate and this is going to be the second coordinate. Okay, so we can say this is x1, y1, right? And this is x2, y2. Or we can do it the other way around. We can say this is x2, y2, and this is x1, y1. It doesn't matter which one do you want to be the ones and which one do you want to be the twos. Anyway, if you use 2 here, both of them have to be 2. If you use 1 here, both of them have to be 1. And same happens here, okay? So in this case, let me just do it like this. I'm just gonna grab this point over here and this point over here, and I'm gonna write the coordinates. What are the coordinates of this point? The coordinates of this point are -4, comma, how many in y? 0, right? And the coordinates of this point are 0 in x and -6 in y, right? So, as I say, I'm going to call this one x1, y1, and this one is going to be x2, y2. What are we going to do? What we're going to do is just to substitute. So, oh, hold on. I'm just going to grab the whole thing over here, right? And I'm going to start substituting. So in this case, I'm going to say this is equal to, who is x1? X1 is -4, right? -4 plus x2. Who is x2? 0. And we divide this by 2, comma, right? y1. Who is y1? 0, which is this one, right? Plus y2. Who is y2? y2 is -6. So I'm going to put it here. -6. And we're going to divide this by 2. Okay, let's solve this. So we can say, okay, -4 plus 0 is -4. And -4 divided by 2 is what? -2. So I can say, okay, this is -2, comma. 0 plus -6 is just -6 divided by 2. What is it? -3. And as you can tell, guys, the answer here is exactly the same as the answer that we got just using our eyes. You see? So this is just to show you guys that sometimes finding the answer is easy. You are the ones who decide to take the difficult path sometimes, right? So please make sure to always pick the easiest way possible. Okay, so in this case, this one and this one is the same answer. Okay. Okay, so now that you understood that, let's go with this one, right? So guys, this exercise is also easy. You could say, okay, this is not a right triangle. Well, I will tell you, check again. As you can see, for example, whenever you have this kind of behavior, guys, that you have 1 and 1, 2 and 2, 3 and 3, 4 and 4, right? It's because we're using, how do you say it? Like 45-degree proportion, right? So it means that here and here, this one is always 45 and this one is always 45, right? 45 plus 45 is 90, yes or no? So it means that this over here should be 90 to obtain 180 over here, right? So what I want to say with this is also a 90-degree triangle, right? So in this case, what's the hypotenuse? The hypotenuse is not this one, is not this one. The hypotenuse is this one because it's the longest side. And remember, if whenever you're in doubt, the hypotenuse is gonna be always the side that is not touched by the right angle. In this case, the right angle is always gonna touch the legs, but will never touch the hypotenuse. So in this case, we can say the hypotenuse is this one. What is the midpoint of this hypotenuse over here? Of course, you can use the formula. You can say, okay, this is the point, this is the another point, this is x1, this is y1, and this is x2 and y2, and then you apply the formula of, okay, that's perfect. But is that the easiest way to do it? Not, probably not. So, okay, so then what is the midpoint? Okay, the midpoint, I can find it using my eyes, right? What is the midpoint? Okay, what are the coordinates of this point? The coordinates of this point is 0, 0, right? In this case, the circumcenter is just right in the middle. So in this case, we're gonna say 0, 0. Okay? And that's the answer. Just that easy. That easy, okay? So, in this case, they are telling you, you have this triangle. You have A, negative 4, comma 5, B, negative 2, comma 5, and C, negative 2, negative 2. Okay? So, I'm gonna tell you how to find the circumcenter in this case. Like, what you have to do is to graph this. Of course, since you are taking the EOC, you're not gonna use like paper to do this. I think the best way to do it is using our beloved tool called Desmos, right? So what are you gonna do? You're gonna type these points over here. So I'm gonna put the points here, A equals, and I'm gonna put here negative 4, comma 5. As you can see, the point pops up there, right? I'm gonna put here B equals, I'm gonna put the coordinates, negative 2, comma 5, right? And the last one is C, which is equal to negative 2, comma, oh sorry, this is point, negative 2, okay? And you have this thing, right? So, let me check that the coordinates are correct. Okay, so to make it a little more understandable, I'm just gonna write this command, polygon, okay? And in parentheses, you're gonna put the letters like this, A, comma, B, comma, C. In this case, this is gonna show you the graph of the triangle. Let me do it like this so you can see it better, okay? So, what are we gonna do? Let me just enhance this a little. I'm gonna make it a little more standardized. I'm gonna put this all of in purple, right? And I'm just gonna put the labels here, right? I'm gonna just probably take a screenshot of this. I'm just gonna put it in your notes. Oh, sorry. I'm just gonna put it in your notes so you have it more illustrative and you can understand better what we're gonna do. Okay, so I'm gonna go here and then I'm gonna grab the triangle that I just have here. Okay, I'm gonna put it here, and as I told you, if you see this triangle, this is clearly a right triangle, right? Because we have a 90 degrees here, a 90 degrees angle here, right? So it means that the hypotenuse is this one. And as I told you, whenever we're finding the circumcenter of a right triangle is always the midpoint of the hypotenuse. So if this is the hypotenuse, the midpoint should be probably somewhere over here, right? So let's try to find, in this case, the circumcenter more clearly. So in this case, guys, what I can tell you is you can do it very easily using Desmos, right? Let me just write something here first, and so you don't spend a lot of time. let's call this our first point. Let me put it in blue here. I'm gonna call this my first point. This is x1 and y1, which is negative 4 comma 5, and this is gonna be our second point, which is gonna be x2 and y2, right? So we're gonna use the formula that we just learned, this one, x1 plus x2 divided by 2 and y1 plus y2 divided by 2, right? So what are you gonna do? You're just gonna go to your Desmos, right? And we're gonna create just another point. This is gonna be our point D, or let's call it the point, I don't know, probably the point M of middle point, probably, or the of midpoint, which is the same, right? It's separated by a comma, and I'm gonna stand here. This is gonna be divided by 2, and this one is gonna be divided by, oh sorry, divided by 2, right? The first one is x1 plus x2 divided by 2, and the other one is y1 plus y2 divided by 2. So what are you gonna do? Just type this thing, x1 plus y plus, okay, x1, which is negative 4. Remember, x1, the formula says, is x1 plus x2. Who is x2? Negative 2, right? Let's put it here. Okay, again, x1 negative 4 and x2 negative 2. Okay, and now let's go with the other part of the formula. The other part of the formula says y1, which is what? 5, right? Plus y2. Who is y2? Negative 2, right? Guys, I always recommend you to use the parentheses. If you don't use the parentheses, the probabilities of making mistakes is bigger. So please be careful with this, okay? So as you can see, this point that we just calculated, which is M, let me change the color, is the midpoint. I'm gonna put it here, right? So you know what? I'm just gonna take a screenshot of the whole thing here, and I'm just gonna put it there, and that's my solution. As you can see, guys, I barely did calculations. If you use Desmos, you're gonna be able to do everything, right? So what I'm gonna do is, you know what? I don't like this anymore. I'm just gonna delete this. I think the best idea here is just to put a screenshot of the whole solution, right? Right? And I'm gonna tell you, okay, the midpoint in this case is, according to my calculations, is negative 3 comma 1.5, right? And how do we do it? Just using Desmos. Okay, so this is again to show you guys that these kind of questions in the test are more about knowing how to use Desmos more than other thing. Okay, so now that you know how to do that, please, I'm gonna ask you to do this one on your own. Well, I'm gonna write classwork, but it's homework or whatever whenever you're watching this video. Okay, so sorry about that. Now let's talk about this second part of the worksheet, which is called, well, it says example number 2. It says given the triangle ABC, where D is the in center. So this is this is key. The in center. So if they're talking about in center, are we gonna use this one or this one? Of course, we're gonna use this one. We are not gonna use this anymore. Remember this part of it. So we're gonna use only this, right? Okay. So given a triangle ABC where D is the in center, in this case, this D over here, just give me a sec. This D over here is the in center, right? And find what is being asked. So guys, these 3 exercises are gonna be done using this figure, right? So of course, each time the information is gonna change according to this figure based on the exercise you're solving. So for this exercise, you're gonna use this to put that information in the triangle, and then when you're done with this exercise, you forget about whatever you wrote from this exercise, you delete it from your mind, and then you just change it for the next one, for this exercise. And then when you're done with this one, you forget about what you did, and then you do this one. But all of them are with the same triangle, okay? So I'm gonna solve the first one to show you what you have to do, okay? So for example, it says if DE, right? DE, what is it? This one to this one. DE is this distance. Let me put it here. So this distance over here, which is DE, right? Hold on. Okay. This distance is 4x minus 1. Let me write it here. 4x minus 1. Okay. And DG, which is DG, it means this one, right? Let me put it here. Is this distance over here? Let me fix it a little. Okay. DG is 6x minus 5. So I'm going to write it here. This thing is 6x minus 5. Okay. Then find who is x, right? Okay, guys. So according to what I told you about the in-center, look, whenever you have an in-center, the distance from the center to the sides of the triangle, right, are the same, right? So therefore, I can say, okay, this distance over here, which is this one, is the same as this distance over here, which is this one, right? So technically, I can say that this is the same as this. So I'm gonna write here, okay. I'm gonna say 6x minus 5 is equal to what? 4x minus 1. And I can solve this in Desmos. I just hope you didn't forget already how to solve this in Desmos, right? So let me show you once again for the people who probably forgot about how to do it in Desmos. Remember that when we're solving in Desmos, what we do is we make this part, oh, hold on. We make this part hold on, give me a sec. Okay. We make this part equal to y, and we make this part equal to y. We put it in Desmos, and then we just solve, right? So I'm just gonna put it here. I'm just gonna go to Desmos, and let's solve this thing, right? So I'm gonna write here, okay, y equals 6x minus 5, and y equals 4x minus 1, right? The solution is gonna be the intersection, which is what? Hold on, give me a sec, guys. I don't know. My Desmos is okay. The answer is 2,7, but remember, as we're looking for x, x is the number on the left, so the answer is 2. What I'm gonna do is just take a screenshot of this, right? Maybe a better one. Let me do it a little here so I have more space. I'll grab this one. Let me put a screenshot of this thing here. I'm just gonna paste it here. Okay. Okay. So according to Desmos, the answer of this exercise is what? 2, right? Because it's the number on the left, which is x. So I can say, okay, according to Desmos, the answer is 2. So is it difficult? Not really. It's very easy, right? So I'm gonna tell you how you're gonna solve the next one. So what I just said is, for the next one, what you're gonna do is, okay, I use this information to put this information here, but for the next exercise, you're gonna imagine that the first exercise never existed. You're gonna forget about this already because you solved it, and now you're gonna put whatever information they're giving you here, you're gonna put it in the triangle, right? So, for example, I'm just gonna give you the first part. So it says df is 2x plus 7. So, for example, df, which is this one, right? What you're gonna do is, okay, I'm gonna say df, which is this one. Hold on. Is what? 2x plus 7. So I'm gonna write it here. This thing is 2x plus 7, right? And so on. So fill whatever information they're giving you here, just put it here and solve the exercise. And when you're done with this one, erase that information and put the new information in the triangle, and that's it. Okay, so you know how to do this. Therefore, I'm gonna say this one is gonna be, or you know what, there's not actually, I know that this is gonna be a homework, so let's call it a homework. All of these things are gonna be homework. Okay, so you're gonna call this one a homework. I'm just gonna copy and paste here, and this one is a homework too, so you know what you have to do, right? Okay,